Welcome to the Explainer. Okay, if you thought you knew Tesla, you might want to completely update your mental model right about now. We're unpacking some truly groundbreaking revelations from Tesla's Q1 2026 earnings call today. And what we're seeing in the data? Well, it isn't just a routine quarterly update, it's the absolute confirmation of a massive structural pivot. We are literally watching Tesla transform in real time from a pure electric vehicle maker into a colossal industrial AI and robotics powerhouse. Okay, let's dive into this, because the sheer magnitude of what Tesla is doing right now is just staggering. I mean, think about it. What actually happens when the undisputed pioneer of the electric vehicle market decides that cars are no longer its ultimate endgame? The shocking reality we uncovered in this report is that Tesla is actively dismantling pieces of its historic flagship car production lines. They're making way for something entirely new. It's a really bold, high-stakes gamble, and we're going to break down exactly how they are pulling it off. To make sense of this massive shift, we're going to navigate through 5 key pillars today. First, the great robotics pivot. Second, Optimus, the blue-collar bot. Third, Cybercab and absolute safety. Fourth, the brains behind the bots. And finally, the $2 billion secret. Starting right off with Section 1, the great robotics pivot, and how they are reconfiguring their core business. This is where we see Tesla's focus fundamentally shifting away from just being a flashy technology showcase, moving straight into a massive, industrial-scale deployment plan. And the biggest economic signal of this entire earnings call happens right on the factory floor. Tesla is actually physically dismantling the legacy production lines for the premium Model S and Model X at its historic Fremont factory. Let that sink in for a second. The final units of those vehicles are expected to roll off the line in early May. They are literally tearing down the very lines that built the Tesla brand, all to build an entirely new mass production infrastructure for the Optimus V3 robot. If you thought Tesla was just a car company, well, this factory floor is where that illusion dies. They are gearing up for industrial mass production from day one. Moving to Section 2, Optimus, the blue-collar bot, taking it from showcase to real-world scale. Going from shiny prototypes to real-world scale is no small feat, so let's look at how this timeline is accelerating. The core engineering platform for the Optimus V3 is now fully functional and honestly remarkably stable. With those final Model S and X units finishing up in early May, the factory floor gets totally cleared out for robotics. But we won't see the true Optimus V3 right away. Elon Musk is strategically hiding the final design under black coverings right now. Why? To prevent competitors from copying their mechanical and aesthetic breakthroughs before they can even launch. The actual big reveal is slated for late July or August, right as they push toward mass production, aiming for initial factory deployment by the end of 2026. And to really understand why this timeline is so incredibly fast, you have to appreciate the sheer mechanical complexity here. 10,000. That is roughly how many unique parts make up an Optimus robot. We are talking about highly complex, high-precision actuators, incredibly intricate robotic hands, batteries, sensors, and an entirely new, never-before-seen assembly line to put the whole shebang together. Building a car is hard, sure, but building a humanoid robot out of 10,000 unique components at a mass-market scale, that is totally unprecedented in modern manufacturing. Now, what's really interesting about this is how it contrasts with our expectations. Sci-fi has kind of conditioned us to expect robots that will instantly fold our laundry or cook a perfect sunny-side-up egg. But Tesla's reality is strictly economic. They're deploying Optimus first for repetitive, physically demanding, and hard-to-staff factory jobs. Think about internal logistics, moving heavy components around, or working continuous, grueling night shifts. Tesla doesn't need this robot to be your perfect household butler on day one. They just need it to solve specific, highly valuable economic problems on the factory floor. All right, on to Section 3. Cybercab and absolute safety. We're looking at a brand new mobility paradigm. Shifting gears from the factory floor out to the streets, the production version of the Cybercab is looking vastly different from the early prototypes. And that's largely thanks to an incredibly advanced manufacturing technique called the unboxed process. So instead of sending a single frame down a long traditional assembly line, different sections of the Cybercab are built entirely in parallel and then sort of snap together at the very end. This process gives these new vehicles a much sleeker, more polished finish, all while drastically maximizing factory space and driving down costs. In this practical rollout, it's happening fast. Down at Giga Texas, the Cybercab fleet has surged from just a handful of test cars to nearly 100 units. If you're in Houston or Dallas right now, you can actually hail a fully driverless ride on their new Android app, which, by the way, just bypassed the previous iPhone waitlists. This means real, fully driverless rides are already active with highly competitive pricing. Going forward, Tesla is phasing the older Model Ys out of this autonomous fleet to make way purely for Cybercabs. It's a very calculated S-curve ramp-up. You start slow to iron out every single millimeter of error, and then you explode in scale.
But as we all know, scale means absolutely nothing without trust, which brings us to this absolutely crucial number, 18. Across all reported Tesla robotaxi operations so far, there have only been 18 total incidents. Of those 18, 16 resulted in absolutely zero injuries. There was one minor injury requiring hospitalization and one minor injury that didn't. Tesla's overriding keyword right now is absolute safety. They are prioritizing a rigorous validation process because they know, for sure, that a single severe failure could completely derail their entire regulatory path.
It all really boils down to this one profound metaphor straight from the report. If Cybercab is the sleek body, then FSD is the soul controlling it. The hardware is ready. They can stamp out these sleek car bodies all day long. But scaling up to millions of passenger rides hinges strictly on public trust and the absolutely flawless, unsupervised execution of that full self-driving software soul.
Which brings us nicely to Section 4, the brains behind the bots. Let's look at the architecture and next-gen compute.
And this brilliantly illustrates the real challenge here. How do you actually control these complex autonomous machines? Tesla uses an incredibly smart two-tier model because you simply cannot rely entirely on a cloud connection for a robot that's handling heavy machinery. Imagine a robot holding a 2-ton car frame and whoops, the Wi-Fi drops. No way. So at the base level, Optimus uses local compute for onboard processing, which allows it to move and function completely autonomously without any cellular or Wi-Fi signals. But for higher-level functions, like understanding a complex voice command or coordinating a fleet of 50 robots across a massive warehouse, Tesla layers in a supervisionary AI, leveraging Grok and XAI. Now, to actually power all this, Tesla's silicon strategy is actively splitting into two paths. The current AI4 platform will continue to support the vehicles, focusing on achieving that highly safe, unsupervised FSD. Meanwhile, Tesla has completed its brand new AI5 chip ahead of schedule, and it's being entirely dedicated to Optimus and their massive data centers. This proves that Optimus isn't just some side project sharing leftover car parts anymore. It's a standalone pillar receiving the absolute bleeding edge hardware. Finally, Section 5, the $2 billion secret. Let's dig into acquisitions and the capital expenditure race. Buried deep in the Q1 financial report was a massive and honestly highly uncharacteristic move. Tesla, a company that is famous for building almost everything entirely in-house, is acquiring a mysterious AI hardware company valued at up to $2 billion. What's really fascinating here is the structure of the deal. $1.8 billion of this payout is strictly tied to real-world performance milestones. Analysts heavily suspect this acquisition is for critical edge AI processors or specialized sensors that are required for Optimus's real-time spatial reasoning and balance. Ultimately, securing this intellectual property is all about Tesla reducing its massive reliance on external suppliers like NVIDIA and TSMC. And reducing that reliance, well, it's expensive. In the 2026 capital expenditure race, Tesla bumped its AI budget up to $25 billion. But to put that into perspective, look at the broader context. Google is spending roughly $180 billion, and Amazon is pushing $200 billion. This isn't just about building cars or robots anymore. This is a high-stakes, planetary-scale tech war to control the future of computing and physical infrastructure. Tesla is realizing they have to spend heavily just to stay in the ring. So, as we wrap up this explainer, we're really left looking at a completely redefined reality. From literally tearing down the Fremont lines, to unleashing driverless cybercabs in Texas, to making billion-dollar AI acquisitions, Tesla is undeniably an industrial robotics powerhouse now. And it leaves us with a pretty provocative thought. It is no longer a question of whether Tesla will successfully build robots at scale. The real question is, how quickly will those robots reshape the real economy, and how quickly will they replace the human workforce? It's a fascinating, rapidly approaching future, and I hope this breakdown helped you see exactly where the data is pointing. Keep learning, and I'll see you in the next one.